Okay, so members, now we have a different question. We are going also to use a different approach, but please don't forget to subscribe to the channel. This one, now they are giving us the height of the pond which was cut before we formed this lampshade or a first term that we have in the question. So how do we go about it? It says the figure below shows part of a circular cone whose original height was 20 centimeters before part of it was cut off. A circular hole of radius 8 centimeters. A circular hole of the solid was drilled through the center of the solid and shown below. So after cutting off the other part, now they drill through a hole here, and then they are asking us that find the volume of the remaining solid. Now they want the volume of this remaining solid. What we are going to do, we are going to get the volume of this first one. Then we get the volume of the whole of this. Now this is rendering. Then after the sum of the two shall be having the volume of that remaining thing. So now what do we do? We start by extrapolating this here. So if I extrapolate so that I be forming the original cone which was there. So I extrapolate this one like this. And also extrapolate the same side, this side, the same way. Now it's that I've been finding, now my vertex there as B. Now, this height, they are giving the height of this cone initially was 20, so I know this height. Now, if I try to draw, now I know that this height B, let me call my center O, and let me call this maybe A. If now I extract out that the same way, always. So if I extract out this diagram, I'm going to be having something like this. Now, why am I doing this? The reason is very simple. Because they want me to get a volume. Of course, to get a volume of this shape here, we need to be having the height. That's why I want to get the height of this. So, if I call this height H, this one is going to be H. So I want to get the height of this. If I know the height of this thing, I'll be able to get also the height of this cylinder in there. So now they are telling that the height of this cone, they are telling that whose original height was 20 centimeters. So the height of this cone here is 20 centimeters. The height of this cone here, the original cone, that's why I'm doing it first. Now, I know that now they are not giving me anything except they are giving me this as 8 centimeters and they are giving me this as 12 centimeters. Now, if I know this height here, now I can get this height here. Now, how am I going to do? Now I need to get this height here, but I'm going to use similarity. Why? Because I'm seeing that this triangle here, B, then we call this one P, and we call this one Q. This one is already O. A. This triangle B2P is similar to triangle BOA. So they are going to use similarity so that I can get the height of this one here. So I'm going to now using similarity. Most of these questions will use similarity when they give you first ones. Using similarity now, we say, what am I going to say? I'm going to say big height. So I'm going to say big height. Big height over the big radius, as simple as that. You say the big height over the big radius over the big radius is going to be equal to the small height as small height. This is as small height in relation as small height over the small radius. The small radius. Now my big height here is of the big triangle. This big triangle is 20. The big radius of this big triangle is 12, equaling to my small height. So that the small height of this small triangle is H over the small radius, which is 8. Why am I doing this? Because we use similarity. It's that this triangle here is similar to this. That's why I'm taking this height, because this is a triangle. I can't use this because this is not a triangle. As simple as that. Now, if we cross multiply here, I'm going to have 12 times this. I have 12h equaling to this times this. I think 160. Is that 9h? If I divide it through by 12 there, if I divide it through by 12, so the answer I'm having is 13.3333 centimeters. So that's the height of this. Now, if I have this height, you see that now my h plus h is equaling to 20. So if I notice is that now my small height here is going to be now 20 minus what I've got here as 13.3333. So that my height there is going to be 20 minus, I get 6.6667 centimeters. Now meaning the height of this first term and the height of the cylinder, I have it now. So after having it now, I need to get now the volume of this first one. So now the volume of, now this can be called the first one or a cylinder, anything. So let me call it first one. The first one is going to be, it's always a third, pi h, then r squared, then plus r squared. So from here, you start our r, the big R, our big R is going to be the big radius, 12, and then our small radius, the small radius which is 8. So substituting, they gave us 5 there. So that times 3.14. Then times the height. Now the height I've got of this, the height of this first one. But from here to here is the height, which is 6.6667 into now 12 squared plus 12 times 8, then plus 8 squared. And pressing this on the calculator, the answer is so the answer here I'm having is 21.2551 centimeters cubed. Now I also get the volume of the cylinder. The volume of my cylinder is going to be, that's given by pi r squared h. So my 3.14 now times the radius of the cylinder. Now, the radius of this cylinder is going to be 8 because the drill is through a cylinder of 8 centimeters. So that's why here I have 8 squared. Then times that the height is going to be the same. Times height, which is our height was 6.6667. And when you put this on the calculator, you have the answer you have here is 1339.74 centimeters cubed. Now meaning that the volume of the remaining solid will be is going to be, now the volume of this first one, which is 1.2551, then minus 39.74. All these are in cubic centimeters. So my is going to be and minus this is going to give me 781.51 meters. So that's how we get members. That's the volume now of this remaining part here. I wish you the best.